everyone, my name is Regina and I'm your host, and you're watching Who Wants to Be a Mathematician, where you prove your mathematical knowledge, and if you win a full scholarship in the best university of the world. Today's contestants are, to my left I have Isabella, and to my right I have Marcela. Remember that to let them know you are finished, you have to grab the calculator, okay? So let's begin. Our problem is 4x plus 3y minus 5, and all that to the cube. Now, Isabella is going to show us how she got the answer to this problem. Isabella?
First, I saw that this was a trinomial to the cube, so I needed to use special products by using this formula, that is a binomial to the cube that gives you a perfect cube polynomial. Then I identified A and B by aligning the signs to make the formulas look the same. So A was 4x and B was 3y minus 5. After that, I substituted the values in the formula, which was 4x to the cube plus 3 times 4x to the square times 3y minus 5 plus 3 times 4x times 3y minus 5 to the square plus 3y minus 5 to the cube. Then I saw that there were two more special products, a binomial to the square and a binomial to the cube. The binomial to the square, I use a formula that gives you a perfect square trinomial. Then I use the binomial to the cube that gives you a perfect cube polynomial. To actually solve the problem, I raised 4x to the cube that gave me 64x cubed. Then I multiplied 3 times the answer of 4x to the square, that 4x to the square is 16x squared, and that multiplied times 3 was 48x squared. And I multiplied 48x squared times 3y, that was 144x squared y, and then 48x squared multiplied times minus 5, that was minus 240x squared. Then I multiplied the binomial to the square, that gave me 9y to the square minus 30y plus 25, and I multiplied 3 times 4x, that gave me 12x, and that. Then I multiplied 12x times 9y squared, that gave me 108xy squared. Then 12x times minus 30y, that gave me minus 360xy. Then 12x times 25, that gave me 300x. And then I expanded 3y minus 5 to the cube with the formula of binomial to the cube. That gave me 27y to the cube minus 135y to the square plus 225y minus 125. Then I grouped all the terms together, and this was my answer.
Okay, Isabella, it's correct. Now, let's see if Marcela got something similar. Marcela made some common mistakes. Like in this part, you missed two special products, the binomial to the square and a binomial to the cube. Let's continue with the next problem. Cube root of x and y to the square times the fourth root of x to the cube and y times 6th root of x to the cube and y to the square. Okay, Marcel got it first. Let's see your answer.
When I saw the problem, I realized that it was a multiplication of radicals, but I also noticed that all of the radicals had different index. So to be able to build them all together, I had to turn all of the exponents in the variables into fractional exponents. And to do that, you have to take the exponent of the variable as the numerator and the index as the denominator. So here would be x 1 over 3, y 2 over 3 times x 3 over 4, y 1 over 4 times x, 3 over 6, y, 2 over 6. And then to be able to multiply all of that, you have to add the exponents because of law of exponents. When you have exponents that are multiplied, you have to add them. So I wrote all of the exponents of the x and all of the exponents of the y. And to be able to add them, of course, you have to find the least common denominator between all of the denominators. So between 3, 4, and 6 will be 12. And to find all the numbers that go above, I had to multiply the numerators by the numbers that the denominators were multiplying by. So if, for example, in here, it would be 3 times 4 gives you 12, so 1 times 4 would be 4. 4 times 3 gives you 12, so 3 times 3, 9. 6 times 2, 12. 3 times 2, 6. And after I added all of them, it gave me 19 over 12, that would be the exponent of the x. And I did the same with the y. So 3 over 4, 3 times 4, sorry, 12. 2 times 4, 8. 4 times 3, 12. 1 times 3, 3. 6 times 2, 12. 2 times 2, 4. And when adding them, it gives me 15 over 12, that is the exponent of the y. So I changed the exponent to be, instead of fractional, to be radical again. So it gave me a 12 root of x to the 19 and y to the 15. Then I separated the ones that would give me perfect 12s and the rest of the exponents, that would be x12 and y12, and the 12 root of that, and 12 root of x to the 7th and y to the 3rd. So I just got these ones out of the radical, and it gave me the final answer, xy times 12 root of x7 and y3rd.
Perfect. Now, let's check Isabella's problem. I noticed you also made some common mistakes. First of all, you cannot multiply indexes. You need to do what Marcela did. Also, when multiplying variables, you add the exponent, not multiply them. So, it was a tie. We can see they are both great mathematicians. See you next time.